Hi everyone. Today we are going to continue talking about factoring by learning about factoring by grouping. Factoring by grouping kind of feels like magic when it works like it's supposed to, and it really only works in some very specific circumstances, but when it comes up, it's really a very convenient way to split things into factors pretty quickly. It's sort of the thing that you would go to after you've tried everything else. So for example, this first problem listed here, if I were to try to pull out a GCF of all four terms, there's nothing that all four of them have in common. Okay, hopefully you're seeing that there's no one thing that all four of them have. So I can't pull out a GCF. It's certainly not a trinomial, so I can't use any of my trinomial tricks. There's no perfect squares or anything like that. But what I do notice is while there's not a GCF for all four terms, these two share something in common, and these two share something in common. So what I'm going to do is I'm going to do like mini factoring. I'm going to factor this piece, and I'm going to factor this piece separately with a GCF. So when I look at these two, they have a 2 in common as a factor, and both terms have an x in them. And so then if I look at what's left over, this term would have a y left over, and this term would have a 2z. Okay, so I took out the 2x and I'm left with a y and a 2z. But then I still have this piece over here. So let's tack this on with addition. And now let's do the same thing over here. So if I look at 3y and 6z and ask what they have in common, they share a 3 in common. And that's about it. They don't have any letters in common. So if I take out the 3, here I'm left with a y, and here I'm left with a 2z. So this is what I mean when I say that this feels kind of magical, is I did this with this piece and I did this with this piece, and after I did that, what I can see now is that they share this piece in common. They share this y plus 2z in common. I couldn't see that the way it was written before, but by rewriting it this way, I can see that this is a factor of this chunk, and this is a factor of this chunk. So now I can pull that GCF out as a factor. This goes back to like the very first day of factoring we did. So I'm going to pull this y plus 2z out as a common factor. Okay, so I pulled that out of both of these pieces, and now I'm looking at what's left. What's left is a 2x and a plus 3. And if you went through and FOILed this thing back out and did all the multiplying, and I don't think you'd have any like terms you could combine, but if you got all your pieces, this is what you would be left with. Okay, so we were able to successfully factor this thing by grouping these two together and these two together, doing a GCF of each one of them separately, and then taking that parenthesis they have in common and pulling that out like a GCF at the end. All right, so let's try that with this next one. And sometimes you do have to rearrange terms a little bit to get ones that have something in common for grouping to work. In this case, I think these look pretty good. These two definitely have something in common, and these two have something in common. Okay, so out of these first two terms, I see that they share an m squared. And so if I take m squared out of m cubed, I would have an m left over. And then here I'm going to have a 2 and an n left over because I took out the m squared. Whoops, 2n, sorry. Okay, these two terms, because they're both negative, I'm going to say that they share a negative 3, and then they both have an n in common. Okay, so with this first one, if I take out a negative 3 and an n, I'd be left with an m. And if I take out a negative 3, I'd be left with a positive 2. And let's see, I took out one n, so from that n squared, I would have one n left. Okay, that worked out nicely, right? This and this match. So I'm going to put that parenthesis out first. Really doesn't matter that it's first, but that's kind of the idea with GCF, is that you put it in front. And then I'm going to say what's left over, this m squared minus 3n. Now I do want to check these, and here's why I'm saying this. I do want to check these to see if I can factor any further. And what got me thinking along those lines is looking at this one. When I saw the m squared minus, my brain was sort of gearing up for that difference of two squares. If this had been something that was a perfect square, I could potentially factor this piece down further. Now, it wasn't in this case, and this would just be where I would leave my answer. But you do always want to look at your factors once you're done factoring and make sure that they can't be broken down any further. Okay, so that's factoring by grouping. You're going to do just a few problems on the factoring by grouping that focuses specifically on that. This process, though, really feeds into the next type of factoring you're going to learn about, which is another type of trinomial factoring. So you kind of have to know this to be able to do that other lesson, okay? And that's it for today. All right, have a great day.